Just after the Big Bang, when the universe was still a chaotic sea of energy, the first atoms began to form. From this formless void, stars ignited, galaxies swirled into existence, and cosmic structures emerged. For centuries, humankind has looked up at the night sky in awe, wondering how it all began. But the real answers were hidden, obscured by time, distance, and the limits of our technology. Now, thanks to a telescope that took more than 2 decades to develop, we are closer than ever to discovering how the universe was born and how it evolved. That telescope is the James Webb Space Telescope, arguably the most powerful space observatory ever built. Unlike any other scientific instrument before it, Webb is designed to look farther back in time than ever before, offering us a glimpse into the very origins of space and time. It was launched on December 25, 2021, as a joint project by NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. This telescope represents a technological leap in our ability to observe the universe, equipped with a suite of infrared instruments so advanced that they can detect the faintest light from galaxies formed just hundreds of millions of years after the Big Bang. The James Webb Space Telescope, or JWST, differs from its predecessor, the Hubble Space Telescope, in fundamental ways. While Hubble primarily captures visible and ultraviolet light, Webb focuses on the infrared spectrum. Why infrared? Because the universe is expanding, and as it does, the light from the earliest stars and galaxies stretches into longer wavelengths. This process, known as redshift, makes those ancient cosmic signals invisible to traditional telescopes. But Webb can see them. It is designed precisely to capture that faint, redshifted light, allowing it to peer further back in time than any observatory in history. And what it has found is reshaping our understanding of the cosmos. One of Webb's first missions was to point its sensors toward a small, seemingly empty region of the sky. What it revealed shocked scientists. Hidden in that narrow view were hundreds of ancient galaxies, some dating back to just 300 to 400 million years after the Big Bang. These galaxies were not only visible, they were unexpectedly massive, structured, and luminous. According to established theories in cosmology, such complex structures should not have existed so soon after the Big Bang. The early universe was thought to be too turbulent, too chaotic for galaxies to take on recognizable forms. Yet Webb showed us images of spiral galaxies, star-forming regions, and elements heavier than hydrogen and helium, all of which suggest a level of maturity we didn't think was possible at that point in cosmic history. This is not a minor adjustment to our theories. It forces us to reconsider everything we thought we knew about how galaxies form and evolve. Some scientists now believe that either the universe formed these structures faster than expected, or that our models of physics in the early universe are incomplete, or possibly both. But the revelations didn't stop there. Webb has also been instrumental in studying exoplanets, worlds that orbit stars outside our solar system. It has already observed several of these distant planets, analyzing the composition of their atmospheres with unprecedented detail. For the first time, scientists can detect specific molecules in the atmospheres of exoplanets hundreds of light-years away, including water vapor, carbon dioxide, and methane. These are the chemical signatures of potential habitability. In one of the most exciting discoveries, the James Webb Telescope detected carbon dioxide in the atmosphere of an exoplanet located in the habitable zone of its star. This is a key indicator because it shows that the planet may have conditions suitable for liquid water, and possibly even life. What makes this possible is Webb's near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, which break down light into its component wavelengths. These instruments allow scientists to study the chemical fingerprints in light as it passes through or reflects off an object. Whether it's a planet's atmosphere or the dusty clouds surrounding a newborn star, Webb can analyze the composition, temperature, and structure with a level of detail that was unimaginable just a few years ago. In another instance, Webb observed a region of the sky known as the cosmic cliffs, located in the Carina Nebula. These towering, cloud-like formations are actually stellar nurseries, regions where stars are actively forming from clouds of gas and dust. The stunning images captured by Webb revealed intricate details of star birth, including the outflows of gas and jets of material that new stars emit as they form. Never before have we seen these phenomena with such clarity. These observations are not only breathtaking, they're scientifically revolutionary. By examining how stars form and evolve, we gain insight into the life cycle of everything in the universe, including ourselves. After all, the elements that make up our bodies, carbon, oxygen, nitrogen, and iron, were all forged in the hearts of stars. Understanding star formation is, in a way, understanding our own cosmic heritage. But there's more. Webb is also turning its gaze towards some of the most mysterious objects in the universe, black holes. Already, it has provided evidence that supermassive black holes may have existed much earlier than previously thought. These colossal objects, millions to billions of times the mass of our Sun, lie at the centers of most galaxies. How they formed so early, and how they grew so large, is still a mystery. Webb is helping to solve it by capturing light from quasars, bright beacons powered by black holes feeding on surrounding material. Some of these quasars have been detected at mind-boggling distances, meaning their light began its journey to us more than 13 billion years ago. Webb's instruments allow astronomers to analyze the environment around these quasars, revealing how they influence the formation of galaxies and stars nearby. This has profound implications not just for astronomy, but for our entire understanding of spacetime. You see, the universe is not static. It is expanding, and this expansion is accelerating due to a mysterious force known as dark energy. By looking deep into the past, Webb gives us data points across billions of years of cosmic history. This helps scientists map the rate of expansion and refine our understanding of dark energy, one of the greatest unsolved mysteries in physics. All of these discoveries raise a tantalizing question. If we were so wrong about the early universe, what else might we be missing? Perhaps the most humbling realization is that we are only scratching the surface. Webb is just at the beginning of its mission, and already it has overturned decades of scientific consensus. It has shown us galaxies that shouldn't exist, stars being born in unimaginable ways, and the chemical fingerprints of potentially habitable worlds. Every new image, every new dataset from Webb, is a piece of a cosmic puzzle we didn't even know we were missing. It challenges our assumptions, forces us to think bigger, and inspires us to ask questions that once seemed beyond reach. We are witnessing a revolution in our understanding of the universe. And it's only just begun. So, what does this mean for us? It means the universe is far more dynamic, diverse, and complex than we ever imagined. It means that we are no longer passive observers, staring at stars with wonder. We are active participants in the quest to understand the very nature of reality. The James Webb Space Telescope is more than just a machine. It's a time machine, a cosmic archaeologist, and perhaps our best hope of answering the most profound question of all. Are we alone? As Webb continues to look deeper, further, and more precisely than ever before, one thing is certain. The universe still has many secrets left to reveal. And we are finally ready to hear them.